So as we discussed in the last session about the resistance, resistance means the property of a material to stop the flow of the charges. So material, when they try to stop the charges to flow, we call this property as a resistance. And if you want to calculate a resistance, resistance is basically a ratio between voltage and current. V divided by I will give us the resistance of the material. Then there are different factors on which resistance depends on. Resistance depends on the length. Number one, the resistance depends on the length. So longer wire will have high resistance than shorter wire. Like example, if the wire is 5 meter long, it will have more resistance compared to a wire which is only 1 meter long. So if we have example two wires which are of different length, same area but different length. So wire, the sample A is example 5 meter long and sample B is 3 meter long. Which one you think will have a high resistance, more resistance, A or B? Which one you think will have a high resistance, A or B? Yeah, that's right. A will have the high resistance because when wire is longer, the charges have to pass through a greater length. That's why the resistance also increases. So we can say resistance is directly proportional to length. So how we represent whenever two quantities are directly proportional, we say R is proportional to L. This is how we represent mathematically when two quantities are directly proportional. What does it mean? It means if a length is double, resistance will be double. If length is 3 times, resistance will also be 3 times. So example, say I have a wire of 5 meter long, which is having a resistance of 100 ohms. The unit of the resistance is ohm. Now we have another wire which is 10 meter long. So what is the change in the length? Originally it was 5, now it become 10. So what is the change in length? The change in length is twice, like the length become twice or double. So if the length become twice, what will happen to resistance? The resistance will also be twice. So if 5 meter is having a 100 ohm resistance, then 10 meter will have the twice, because the length is double, so resistance will also be double. So 100 ohm, the 10 meter will have 200 ohm resistance. Same way, if we have another wire which is 15 meter long, so what happened compared to the first part? What happened to the length? The length become 3 times. Like first it was 5, now become 15, so it means the length become 3 times. So if the length is increased by 3, what happened to resistance? The resistance will also increase by 3. So if it was 100 ohm for 5 meter, for 15 meter, it will be how much? It will be 300 ohms. So the first factor on which the resistance depends, that is the length. So if you increase the length of the wire, the resistance will also increase. So if you double the length, resistance will be double. If you triple the length, the resistance will be triple. Is it clear how the length affects the resistance of the wire? The second factor on which the resistance depends is a cross-sectional area. So resistance also, the second factor on which the resistance depends, that is a cross-sectional area, or we also say area. So resistance is inversely proportional to area. What does it mean? If we have a thinner wire, they have more resistance than thicker wires. So example, you have two wires A and B. Which one you think will have the high resistance? A or B? Which sample, both have the same length, but they have different areas. Which one you think will have the high resistance or greater capability to stop the flow of the charges? A or B? A will have high resistance because A is having a narrow passage. A is a narrow passage for the charges to flow, and B is having, it's a wider passage. So if it is a wider passage, the charges can flow easily. So like example, if two charges are moving through A and two charges are moving through B. So through A, the charge, because the passage is narrow, so charges find it difficult to move. But for in B, because the passage is wider, so charges find it easy to move. So when the charges find it difficult to move, it means high resistance. When charges find it easy to move, it means it has low resistance. So thinner wire will always have high resistance than thicker wires. So resistance and area are inversely proportional. Whenever we say inversely proportional, it means if I decrease one quantity, the other quantity will increase. And whenever two quantities are inversely proportional, if one is increasing, the other will decrease. Example, we have area and resistance. So example, we have area of 2 meters square and that is having a resistance of 100 ohm. If we double the area, like example, the area is twice, area become 4 meters square. So what happened to resistance? So if area is increased, the resistance will decrease. So it will also decrease by factor 2. If area is double, the resistance will be half. So here area become twice, so resistance will become 50. Same thing, if we have like example area of 6 meters square. So what happened? Originally it was 2 and now it is 6 meters square. So what happened to the area? Area become 3 times. So if area is increased by 3, what happened to resistance? The resistance will decrease by 3. So it will be 100 divided by 3, which is 33.3 ohms. So whenever we increase the area, the resistance will decrease, and opposite will happen for length. Then how to find the area of the wire? To find the area of the wire, the formula to calculate the area of cross section of wire, there are two formulas depending on what is given. You can use pi r square, means the radius square, or it can be pi d square by 4. So it depends on the question. If they give you the radius, you will use the first formula to get the area of the wire. If they give you diameter, then you will use the second formula to calculate the area of the wire. And if radius is double, diameter will increase by 4. If radius is double, or if radius is double, area will increase by 4 because it is r square. So example, if we say so what is the relation between area and radius or diameter of the wire? So we have the formula area is equals to pi r square for the wire, or area is equals to pi d square by 4. So if we double the radius, the area will increase by 4 because it is square, so it will increase by factor 4. Like if the radius is double, area will increase by 4. If radius is increased by 3, this will increase by 9 because it always increase with a square. It is r square. So what is square of 3? The square of 3 is 9. Same thing, area is pi d square by 4. So same relation is there. If the diameter is double, what happened to area? Area will increase by 4. If its diameter is 3 times, what will happen to area? Area will increase by 9 because it increases with a square. So always remember in the question, sometimes they change the radius or a diameter. So what happened to area? The area depends on the diameter and radius is square. So if radius is double or diameter is double, the area will increase by 4. So we have the relation that resistance is directly proportional to length and resistance is inversely proportional to area. So directly proportional means if we increase one quantity, the other quantity will also increase. Or if we decrease one quantity, the other quantity will also decrease. Whereas inversely proportional means that if we increase one quantity, the other will decrease, and opposite will happen if we decrease the other quantity, first quantity, the other quantity will increase. So between length and resistance, they are directly proportional. Whereas length and area, length of the wire or area and resistance, they are inversely. Like if we increase one, the other will decrease. So example, if I say I have a wire which is 2 meter long and that is having a resistance of 100 ohm. What will be the resistance of a wire which is 10 meter long? So how to identify, how to predict the resistance? So what is the change? Because, yeah, that's good, Abdullah. So because originally it is 2 and now it becomes 10. So it means how, with what factor it increases? So it increases by factor 5. So if it increases by factor 5, what will happen to resistance? The resistance should also increase by factor 5. So it will become how much? It will become 500 ohms. But resistance and area are inversely proportional. Like example, if I say we have an object which is having an area of 2 meters square, and example was resistance 100 ohms. And now it become 10 meters square. So 2 meter become 10 meters. So by what factor it changes? It is changes by 5. So what happened to resistance? This will decrease by 5. So by factor 5, so it will be 100 divided by 5. So 100 divided by 5, that's equal to 20 ohms. So the resistance will be equal to 20 ohm. So if you increase the length, the resistance will increase, and if you increase the area, the resistance will decrease. So if we have two wires which are made up of same material and we want to compare their length, resistance and area, so if two wires which are made up of same material, they have different lengths, they have different areas, and we want to compare them with each other. Like example, the length, this is area, so the area of this wire, example A1, its length is L1. So length is L1 and resistance is R1. For this one, area is A2, length is L2 and resistance is R2. So the formula which relate this resistance, like comparing resistance, area and length for two wires which are made up of same material. So the formula is R1 A1 divided by L1 equals R2 A2 divided by L2. So we will use this formula to work out the resistance, because if both area and the length changes, so we can use this formula to work out the resistance of a sample. I will solve a question. Like example, if I say the resistance of this one is 10 ohm and its area is 2 meters square and its length is 5 meter. We want to find the resistance if the area is like example 3 meters square and the length become 10 meter. So here area and length both are changing. When it was having an area of 2 meters square and length 5 meter, example, its resistance was 10. But now its area is 3 meters square and length is 10 meter. What is the resistance? So we will always use the formula R1 A1 over L1 equal R2 A2 over L2. So R1 is the first resistance. So originally it was how much? It was 10 multiplied by A1, that is 2, divided by L1, the length, that is 5, equal R2, we don't know, A2, that is 3, and L2, that is 10. So when we simplify this, 10 multiplied by 2 is 20. So this is 20 divided by 5 is equals to this R2 multiplied by 3 divided by 10. So we simplify 20 divided by 5, that's equal to 4. So R2 into 3 divided by 10. This 10 is divided, other side it will be multiplied, and this 3 is multiplied, other side it will be divided. So 4 multiplied by 10 is 40 and 40 divided by 3. So 40 divided by 3, that will give us the value for the new. So the new resistance is how much? It is 13.33 ohms. So whenever both length and area are changing, we can use this formula R1 A1 over L1 equal R2 A2 over L2. But if only one is changing, like if in the question if length is double, then we can say resistance will be double. Or if area is double, it means we can say resistance will be half. But if both of the factors are changing, in that case, if both factors are changing, in that case, what we have to do, we have to use this formula. Is it clear? This formula, how we can relate the area length of two wires which are made up of same materials. Any doubt till this point? Now we'll do some questions related to the resistance. Now questions related to topic resistance. So the question is, the table describe 4 different resistance wire. They are made up of same metal. Which is having the smallest resistance? You can also use the chat to state the answer. Remember, resistance is directly proportional to length. We want a smaller resistance, so we want a shorter length. And resistance is inversely proportional to area. So if we want less resistance, we want more area. So more area and diameter are proportional. So if diameter related to area, so we want greater diameter and we want shorter length. So when we check which is having a shorter length and greater diameter, so you can clearly see B is having a shorter length which is 2 meter long and diameter is 1.5. So B will have the least resistance. Is it clear? The first question. So whenever we want to decrease the resistance, we should reduce the length and we should increase the area. Another question, so you will find like many questions relating the area and length. The diagram represents 4 copper wire which is having the greater resistance. So resistance and length are directly proportional. So we want a more resistance means we need a longer wire. And resistance and area or diameter are inversely proportional. So if we want a greater resistance, we want a thinner wire. So the wire should be thinner and it should be longer. So which wire is thinner and a longer? So when we check A, B, C, D, C and D are the longer wire. And which is thinner? C is thinner. So it means C will have the highest resistance because C is having a small area. C is having a small area, so high resistance, and C is longer. That's why it will have more resistance. So increasing a length will increase the resistance, and decreasing a area will also increase the resistance. Another question, so similar question you will find every time they're relating length and area with the resistance. So in this question, we want a largest resistance. So if you want a largest resistance, it means the length should be more so that it will be larger, and area should be small to have a larger. So area or diameter should be small. So diameter should be small, so either A can be answer or B. And length should be longer, so it means it will be B. Because thinner wires have high resistance than thicker wires, and longer wires have high resistance than shorter wires. Is it clear, discussion? Which circuit is should be used to measure the resistance? Whenever we want to measure a resistance, we need a voltage and we need current. And how we get the voltage? We get a voltage by a voltmeter. And how voltmeter should be connected? Voltmeter should be connected parallel. To get the current, we need ammeter. And how ammeter is connected? I is the current, and to measure the current, the device which we use, we call that as ammeter. And ammeter should always connected in series. So voltmeter symbol is V, that should be parallel, and ammeter symbol is A, that should be series. So here ammeter is connected correctly, but voltmeter is wrong. Why? Because voltmeter they connect in series. Here voltmeter is connected correctly, but ammeter is wrong because ammeter should be in series. Here voltmeter is wrong because that is in series, and ammeter is also wrong, that is parallel. And D, ammeter is connected in series. Series means one way for the charges to flow, and parallel, when we have different connections, like different path for the charges to flow, that's parallel. So voltmeter is connected correctly and ammeter is also connected correctly. That's why D is the right answer. Is it clear, discussion? Then which graph shows a characteristic ohmic resistance? Ohmic resistance means which is having a which resistance is constant, that's called ohmic resistance. And filament, the resistance increases. So here when we check here, this is totally wrong because this is not having like voltage is increasing but the current does not change, so this is totally wrong. Here what happened, whenever we have a straight line, whenever you have a straight line, it means X is having a constant resistance. And constant resistance means this is known as ohmic resistance, because ohmic resistance, their resistance is constant. So X is a ohmic resistance. What about Y? As you can see, when current and voltage graph is there, what slope is inversely proportional to resistance. So if the slope is decreasing, as you can see here, the slope is decreasing, it means the resistance is increasing. And for a device which, or for a component which resistance increases, that is a filament. So Y is a filament. Why it is a filament? Because with the passage of the time, filament temperature increases. As its temperature increases, the resistance increase. So Y is actually a filament. What about Z? What is happening for Z? Again, when we have a current and voltage graph, the slope is reciprocal to R. Like if the slope is increasing, it means the resistance is decreasing. So for this component, what is happening to resistance? The resistance decrease. Because slope and resistance are inversely proportional for current and voltage graph. If slope increase, it means the resistance is decreasing. And resistance decrease, so it means what is this? This is a thermistor, or we can also say a semiconductor. So they're asking which component is a ohmic resistance. So ohmic resistance, that is X, and which one is a filament, that is Y. So ohmic resistance is X and filament is Y. That's why option B is the right answer. Is it clear, discussion? Then a cylinder, conducting putty has a length L and a diameter D and resistance R. Now it is mold. The diameter is 2D and it has the same volume. By what factor does the resistance decreases? So we have to find by what factor resistance has changed. Look, we know resistance and length are directly proportional, and we know resistance and area are inversely proportional. So first it was having a length L, but what we did, we double the diameter. If we double the diameter, what will happen to area? Because area is pi d square by 4. So if we double the diameter, if the diameter is double, means multiplied by 2, because it is a d square, so area will increase by 4. So the area will increase by 4. And what happened to length? Because it is having a same volume or a constant volume. If we have a constant volume, if we increase the area, because volume is area multiplied by length. So when the area is increased, the length should decrease to have the same volume. So if area is multiplied by 4, the length should be divided by 4. So if area is increased by 4, to get the same volume or constant volume, the length should decrease by 4. So what is the change in the length here? The length has decreased by 4. If length is decreased by 4, what will happen to resistance? The resistance will also decrease by 4. And what happened to area? Because the diameter is double, if diameter is double, area is increased by 4. So if area is increased by 4, what happened to resistance? The resistance should decrease by 4. So due to the change in length, the resistance decreases by 4. Due to change in area, the resistance also decreases by 4. So it will be resistance decreases by 4 due to length, and it is decreases by, due to the change in area, it also decreases by 4. So it is divided by 4 and 4. So total 4 multiplied by 4, that is equals to 16. So means the total resistance decreased by what factor? It will be 16. This is one way of solving. There is also another one, another formula, which whenever both resistance and length are changing, we can use the formula R1 A1 over L1 equals R2 A2 over L2. That's the second formula. And whenever both are changing, we can use this formula R1 A1 over L1 equal R2 A2 over L2. So example, the first resistance is R. R1 is equal to R. What about area? Because the diameter is example D, so example area is A. The first area is A. And what about the length? The first length is L. Now what happened? That it is molded into a diameter 2D. So if the diameter is double, because the relation between the diameter and area is pi d square by 4. So if diameter is double, area will increase by 4. So it means we don't know the new resistance, but what happened to new area? The new area will be 4a. Why 4a? Because the diameter has double. So when diameter is double, area is pi d square by 4. So area will be 4 times. And because it is having a constant volume, so if volume is constant, if area is multiplied by 4, the length should be divided by 4 to make the constant volume. Like the volume should not change. So what happened to the new length? The new length is divided by 4. So new length is L by 4 or quarter of L. Now we simplify this. So when we simplify this formula, area will cancel with area. This A will cancel with A. This L will cancel with L. And this is 1 by 4, so it will move up. So it will be 16. So R is equals to R2 multiplied by 16. And this is 16 is multiplied, other side will be divided. So R by 16 is equals to R2. Means the new resistance will be will decrease by 16. That's why D is the right answer for this. So whenever we increase the area, whenever we increase the diameter, the area will also increase but vary with a square. Is it clear discussion? Yes, Abdullah. So that's why D is the right answer for this. Then a student measure the potential across a device and the current, which calculation give the resistance. So to get the resistance, resistance is voltage divided by current. So not addition, not current divided by voltage. It is potential difference or voltage divided by current. So C should be the right answer. That's a formula to calculate the resistance. Which two changes to a metal wire increase the resistance? So we know resistance is directly proportional to temperature for a wire, resistance is directly proportional to length, and resistance is inversely proportional to area. So what we should do, area is not area is mentioned here, like we want to increase the resistance. So if we decrease the length, the resistance will decrease. If we increase the temperature, the resistance will increase. So one factor is decreasing, other is increasing, so it cannot be an answer. When we check, increasing a length will increase the resistance and decreasing a temperature will decrease the resistance. That is also wrong, because one of the factors is increasing the resistance, the other is decreasing the resistance. Because the temperature, when we decrease the temperature, resistance also decreases. And if we increase the temperature, resistance also increases. When we check decreasing a thickness, so if we decrease the thickness, we reduce the area, the resistance will increase. And increasing a temperature will also increase the resistance. So both factors are increasing a resistance. So C should be the answer. Why not D? Increasing a thickness, if we use thicker wire, that will reduce the resistance, and if we decrease the temperature, that will also decrease the resistance. So both will decrease the resistance, but we want to increase the resistance. That's why C is the right answer. Is it clear discussion? Any doubt till this point? So to get the combined resistance, these two are in parallel. So these two are in parallel. When two resistors are in parallel, product divided by sum. So 6 multiplied by 12 plus 6. So 6 multiplied by 12, that is 72, and divided by 18. So it will be 72 divided by 18. That is 4. So combined resistance is 4. So this is 4, and next to that 6 ohm is in series. So whenever two resistors are in series, so we will add them 4 plus 6. So that will be equal to 10. So B should be the right answer. So whenever we are finding the combined resistance, if they are in parallel, the formula is a product divided by sum. And when they are in series, we just simply add them. So these are some questions related to topic resistance.